Hi there. My name is Anselme Dossou, and I'm a second year PhD student in the Earth and Climate Sciences program at Duke University's Nicholas School of the Environment. I'm the lead author on a new study on toxic metals in soils and structural ash in Los Angeles following the 2025 Palisade and Eaton wildfires. Our work was recently published in the peer-reviewed journal Environmental Science and Technology Letters, a leading venue for environmental research. You can find a link to the paper in the notes below this video. This project grew from a collaboration between Robin Jones, owner of the Los Angeles culinary garden design firm Honey Girl Grows, and our Duke-based team led by my advisor, Professor Daniel Richter, and me. Other participants included homeowners in both fire zones and across LA, as well as Chapman University archaeologist Justin Walsh and Pacific Palisades high school student Oliver O'Donnell.
Hi, I'm Robin. This project began while the fires were still burning. Through social media, I began to receive questions from dozens of followers and clients asking me if it would be safe to eat the food grown in their edible gardens and orchards around Los Angeles after the fires. I couldn't find enough research to help me answer these questions, and it was so worrying I couldn't sleep. So I discussed this problem with my partner, Justin.
Hi, I'm Justin. I connected Robin with Dan since we had collaborated on other research before, and I knew he was an expert on polluted urban soils. I didn't realize at the time that he had also written his own PhD thesis on the relationship between soils and fire.
And hi, I'm Dan, the professor of soil science. I was excited by the possibility of helping people in Los Angeles and in other places around the world by contributing some new knowledge that was clearly lacking. What is the effect on soil of 16,000 structures burning at the same time? No one knew. These kinds of fires are happening frequently and on larger scales in what scholars call urban wildland interfaces.
We were able to meet on the morning of January 25th, 2025, which was lucky because later that day it rained for the first time since the fires. Together, we agreed on sampling strategy that would allow us to get several data points at 2 depths from every property that we sampled. We would sample soil at the curbside, in yards, and adjacent to houses if they were still standing, or from within their footprint if they had burned. The samples were made from the surface soil and from 5 centimeters, which is about 3 inches, below the surface at each location for comparison. Once we made the samples, we mailed them to Duke in Durham, North Carolina.
A key component of this work was relying on Robin's network. This was a true community science project. We made videos showing how to take samples so that everyone was doing it the same way.
Justin and I went out and took dozens of samples ourselves. First across Los Angeles on January 25th to create a baseline, then in Altadena, and finally in Pacific Palisades, which we originally could not access because it was closed except to homeowners. In the first phase of sampling in the January-February 2025, we sampled 32 properties.
Hi, I'm Oliver. I've lived and gone to school in the Palisades for my entire life until the fire. As an avid beekeeper and gardener, I also had questions about the condition of the soil after the fires. I was lucky enough to land in Robin's network and help the team with sampling soil. In order to do so, we had to make sure to wear protective gear to gather the soil samples in the Palisades. While it was tough to rummage through the remains of my friends and neighbors' houses, it felt amazing to be able to do something great for the Palisades in Altadena, as well as aid the scientific community.
This study, we focused on lead and arsenic because these metals are linked to serious human health concerns, especially for children. Toxicological studies show that even relatively low blood lead levels are associated with cognitive, behavioral, and cardiovascular impacts, and there is a broad consensus that exposure to lead at any level is unsafe. Arsenic occurs naturally in soils and has also been widely used in wood preservatives, insecticides, paints, and other household products. It is a known carcinogen metal with complex site-specific screening levels. In contrast, the other metals we measured primarily serve as tracers of different construction materials and household products in structural ash. They help us interpret sources and burning conditions, but lead and arsenic are indicators of potential long-term health concerns for residents. For the simple analysis, our Duke team included Leon Kelly and Louis Lowe, who are also co-authors on this work, along with me and Professor Richter. After the samples arrived at the Duke Soils Laboratory, we air-dried them, removed large debris, and finally pulverized the material. We then analyzed about 5 grams of each sample using a calibrated portable X-ray fluorescence instrument to measure 10 different metal and metalloids, ensuring high quality and reliable data for the study. Before sharing the soil analysis result with homeowners, we consulted with Duke's Institutional Review Board and Office of Counsel, obtained written consent from individual residents, and provided those results only to the homeowners who chose to receive them.
During our analysis, the government's response to the LA wildfires came more into focus. Prior to our sampling, the Army Corps of Engineers had removed containers of hazardous chemicals and materials, such as large lithium batteries. Following this work, homeowners were asked to choose if they wanted the Corps to complete a second phase of cleanup, meaning the scraping or the removal of about 6 inches of surface material from the footprint of the burned home, plus a margin around the house of about up to 6 feet. In this photo of a Pacific Palisades property after scraping, you can see the brown scraped area in the background, while the curbed area and the front yard were left as they were by the Corps. Although in previous fires, the Corps has tested properties after this second phase of cleaning and scraped again if problems were still found, in the LA fires, no post-cleanup testing or re-cleaning was offered.
We were concerned about this process. For example, could cleanup of one property lead to contamination of neighboring ones as dust was raised by the scraping? It also turned out that reconstruction was happening in different ways and at different speeds in the 2 affected communities. We committed to doing more sampling so that we could learn if the Army's cleanup was effective and safe.
In July and August of 2025, Oliver and I resampled 17 properties in Altadena and Pacific Palisades. All of these properties had completed the Army's scraping process, so we could compare results before and after the cleanup.
The cleanup by the Army Corps and other private companies in the Palisades was pretty fast, and there were only a few properties in more complicated lots such as up in the hills that remained uncleared. Unfortunately, the rebuilding of homes has been a lot slower. People are still trying to figure out insurance issues and even some of the building permits that are required.
Before getting into the details of our results, it is important to mention that screening levels for lead in soil refer to risk-based guidelines that help agencies decide when further testing or cleanup may be needed. The U.S. Environmental Protection Agency currently uses a residential soil screening level of 200 parts per million, while California uses a more conservative value of 80 parts per million. These numbers come from different health risk models, but both serve the same purpose of early warning flags and not hard lines between safe and dangerous. In this study, we used both values in tandem to interpret what we found after the fires. In the weeks immediately following the fires, we found that lead and arsenic levels in structural ash were high. Structural ash in our research here refers to the material left in the footprints of burned homes. About 25% of ash samples contained lead above about 400 parts per million and 10% above 650 parts per million. In total, 28% of ash samples were above the US EPA screening level of 200 parts per million, and about half were above California's 80 parts per million level. The highest lead levels were found in the ash from some of the older homes. In our study, homes in Eaton were generally older than those in Pacific Palisades, with median construction years of 1924 and 1948 respectively. The median lead concentration in Eaton ash samples of 105 parts per million was higher than in Pacific Palisades ash samples of 68 parts per million. Arsenic levels in the ash, however, did not show a clear relationship with house age. When we looked at yard soils, about 23% of yard samples exceeded the US EPA's 200 parts per million screening level for lead, and about 56% exceeded California's 80 parts per million level. Some older homes had relatively high lead in their yards, but importantly, we did not find a simple one-to-one link between how contaminated a home's structural ash was and how contaminated its yard soil was. That means each part of a property can tell a slightly different story about contamination. When we then compared samples collected before and after the phase 2 cleanup, in the structural ash area that was scraped and cleaned, lead and arsenic levels dropped substantially, especially in the samples that had been most contaminated to begin with. However, not every ash location ended up below the US EPA and California screening levels. This indicates that cleanup process is generally effective, but not a guarantee that all toxins have been removed in the areas where it took place. Moreover, in burned parts of properties that were not targeted for soil removal, such as yards and curbside strips, lead and arsenic concentrations before and after cleanup were strikingly similar. Because no soil was scraped in these areas, any contamination present beforehand essentially remained in place. For residents, this means that while the official cleanup greatly reduced risks right around the former house locations, it likely did little to change metal levels in the rest of the property. Homeowners should be aware that the cleanup process likely did not have any mitigation effects in areas of their properties where soil was left intact.
The results of this study suggest that you don't have to have an edible garden or orchard to be concerned. You merely have to care about your own health, that of your pets, and your children. So my takeaway is please, please, please test and test again at each step as you move forward so that you understand the risks that might exist on your property. I'm so grateful to all of the homeowners and Duke Lab members for making this study possible.
And I too want to express my thanks to all who helped conduct this amazing research project. This has been a particularly exciting project as it represents a new model in scientific research that relied entirely on volunteers, both sampling soils and ash, and back in the laboratory with sample preparation and analysis. We look forward to continuing this sampling and chemical analysis in the future. If you have any questions for any of us, Robin, Oliver, Justin, Anselme, or me, please reach out via the contact information in the notes to this YouTube. So again, thank you for your attention.